Hello friends, Mr. Burrell here. We just finished Unit 11, all about quadratic graphs. Now we're going to put quadratics aside for the rest of the trimester. You're welcome. I love talking about quadratics. There's lots of units where we talk about quadratics. We talked about factoring, solving, and graphing quadratic functions. Now we're going to kind of steer away from that into a completely different part of math. We're going to start talking about probability. Some basic probability. You've probably heard and had lessons on probability in the past, so that's what we're going to talk about. This unit is on basic probability. So this is just kind of a funny comic. What's the probability that I'll pull a red marble out of this box? 0? Good guess, but try again. He's pulling out of a box of screws. Get it? Because there's no marbles in a box of screws. Anyways. Okay, what is probability? When I say the word probability, what do you think of? Well, probability is a numerical description of how likely an event is to occur. So, how likely is it that something's going to happen? What's the probability that it's going to rain tomorrow? What's the probability that I roll a 1 if I roll a standard dice? What's the probability that I'm going to draw a jack out of a deck of cards? Things like that. That's what probability is. It's a numerical way of describing how likely something is to happen. Okay, so before we start really getting into the meat of probability, we're going to first start talking about notation. We're going to talk about set notation. In the mathematical world, this is going to help us a lot in defining and using and evaluating all these different things associated with probability. So, by the end of this video, these are the things that I hope you're able to do. I want you to be able to write a sample space in set notation. We'll talk about what a sample space is. I want you to know what a subset is and tell if one set is a subset of another. And I want you to know what a union, an intersection, and a complement are and find them. Find the union, intersection, and complement given various sets. If you don't know what those words mean, that's okay because we're going to talk about them now. So before discussing probability, again, it will be helpful to discuss set notation. Here are some kind of basic definitions on set notation. So before I get into these, I would strongly encourage, if you haven't, if you can, I would encourage downloading these guided notes. All of these definitions and all the things, all the stuff that we discuss in pertaining to a probability are in those guided notes. These guided notes are really helpful. Please download them. Take notes as you go through, because that'll be really helpful. If you don't have those guided notes or you don't have access to print them off, go ahead and get a notebook, piece of paper, and take notes with these as we go, because these are going to be really helpful definitions to know about. So first, a set. When I say the word set, a set, put simply, is a group of things. Formally, we could define a set as a collection of distinct elements. So it's just a group of items. Those things could be numbers, items, people, etc. So for example, the set of even numbers between 1 and 10. So all the even numbers between 1 and 10. That's a collection of numbers. The set of numbers between 1 and 5. 1, 2, 3, 4, 5. That's a collection or a group of numbers. The set of appliances in my kitchen. It's a group of things that I can specifically pick out all of those different things. So that's what a set is. It's just a group of things. A group of items, group of numbers, whatever it may be. Set notation, so usually the elements of a set, or the things in a set, are listed inside curly brackets, so we know that we're talking about a set. So for example, the set of even numbers between 1 and 10, in curly brackets, I'll list them, separated by a commas, 2, 4, 6, 8, 10. Those are the even numbers between 1 and 10. The numbers between 1 and 5 I list as 1, 2, 3, 4, 5. The list of appliances the set of appliances in my kitchen I list as oven, microwave, fridge, toaster, all separated by commas. So that's what a set is, written in set notation. I write those in curly brackets, so I know that I'm talking about a set. So sets are usually named with capital letters. So let's denote the set of even numbers between 1 and 10 as set A, the set of numbers between 1 and 5 as set B, and the set of appliances in my kitchen as set C. So set A is equal to 2, 4, 6, 8, and 10. Set B is equal to 1, 2, 3, 4, and 5. Set C is equal to my oven, my microwave, my fridge, and my toaster. So that's how I list sets. And when I list sets throughout this unit, when we're talking about the probability of certain things happening, this is how those sets are going to be written. Okay. Next term we're going to talk about is a sample space. So the sample space is the set of all possible outcomes or elements. So for the rest of these definitions, we'll say that our sample space is U, standing for the universe. All possible numbers in my sample space are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So usually in a problem, we'll define a sample space as all the possible outcomes, all the possible elements. Next term we're going to discuss is a subset, and I denote a subset with kind of this sideways horseshoe-looking thing. A subset is a set in which all the elements are contained in another set. For example, so I have set D here. Let's say set D is the elements 2, 6, and 10. And set A is the set 2, 3, 6, 8, and 10. Just for the sake of argument, let's say that these are two sets. So I'm going to say this. D is the subset of A. So when I see this D little horseshoe A, that's read D is a subset of A, which means that all of the elements of set D are also contained in set A. So notice here I have a 2, a 6, and a 10, and here I have a 2, a 6, and a 10. So since all of the elements that are in set D are also in set A, I say that D is a subset of A. That's what a subset is. Next definition we want to define is an empty set. If a set is empty, or if there's nothing in it, if I have a set with nothing in it, I usually denote it with this symbol. Kind of a 0 with a line through it, which means this set is empty. There's nothing going on there. There's nothing in that set. That's how I define the empty set. Okay, this is a big page, so I need to kind of scroll this up here. So these are the last 3 definitions that we're going to talk about, and kind of some of the most important ones that we'll see throughout this unit. So an intersection. An intersection is denoted with this little kind of cap, a horseshoe facing downwards, and it reads and. So when I talk about intersection, I'm talking about and. So the intersection of two sets, say A and B, is the set of elements included in set A and set B. So when I intersect two sets together, I'm talking about the elements that are both in set A and in set B. So previously in your guided notes, we talked about set A and B. Set A was the set of even numbers between 1 and 10. Set B was the set of numbers between 1 and 5. Let's see. So A was 2, 4, 6, 8, 10. Curly brackets. And B was 1, 2, 3, 4, and 5. Okay, so A intersects B, so this reads, when I have this A upside down horseshoe B, that reads A intersect B is equal to the set containing 2 and 4. So that basically says the intersection of sets A and B is the set 2 and 4 because both 2 and 4 are elements of set A and set B. So notice here's a 2, here's a 4, here's a 2, here's a 4. Those are the only elements that are contained in both of those sets. So that's what an intersection is. The elements that are contained in both of the sets that we're talking about. A union, and I denote that with a U, that's convenient, we usually read or. So the union of two sets, for example, A and B, we'll use these same sets up here again. The union of two sets is the set of elements included in set A or set B, either or. So, for example, using sets A and sets B, if I read A union B, that's how I read this, A union with B, with this little U here, is the set containing 1, 2, 3, 4, 5, 6, 8, and 10. The union of sets A and B is the set 1, 2, 3, 4, 5, 6, 8, and 10 because these are all either elements of set A or set B. So notice if I was going to list all the elements in A or B in a row, I'd list, let's see, 1, 2 and 2, 3, 4 and 4, 5, 6, 8, and 10. That's all the elements in A or B. See that? Well, it's kind of redundant to repeat these, so I don't need to write 2 twice. I don't need to write 4 twice. So that's where I get my union set. 1, 2, 3, 4, 5, 6, 8, 10. All of the elements in either set A or set B. So that's a union. So let me move my face up here a little bit. The last definition we're going to talk about is the complement. So when I say the complement, I denote it with this little exponent, this little small number up here with a C. And I usually think of the word not. So let me explain that. The complement, spelled with two E's here, the complement of a set X is the set of elements not included in X, but still included in the sample space. In other words, it's the set of numbers in U, but not in X. So remember on the previous page, I denoted my sample space to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That was my sample space. That was all the numbers that I was concerned with. And then set A was 2, 4, 6, 8, and 10. So then, for example, this right here, I read A complement, or the complement of A, set A, the complement of set A. The complement of set A is the set 1, 3, 5, 7, and 9, because notice, those are all the elements in the sample space that are not in set A. So in set A, I had 2, 4, 6, 8, and 10 up here. So I don't want 2, 4, 6, 8, or 10. So all that's left in the sample space that's not already in set A is 1, 3, 5, 7, and 9. 1, 3, 5, 7, and 9. So that's the complement. The complement of a set is the set of elements not included in X, or in A or B, whatever set you're talking about, but still included in the sample space. Okay, let's look at some problems here. Okay, so it says use the following sets for the questions below. So here it says the sample space is the numbers between 1 and 20. So right here, the sample space, it says write each set in set notation. So I'm going to go ahead and write the sample space as 1, 2, 3, 4, 5, blah, 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 17, 18, 19, 20. All the numbers between 1 and 20. That's my sample space. So set J is the set of odd numbers. So of the numbers between 1 and 20, my odd numbers are 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Those are all my odd numbers between 1 and 20. Set K is the multiples of 5 between 1 and 20. Well, my multiples of 5 are 5, 10, 15, and 20. Those are all my multiples of 5. Set L is the prime numbers up to 20. Well, my prime numbers are 2, 3, 5, 7, 11, 13, 17, 19. Prime numbers are all the numbers only divisible by 1 and itself. And the set M is the set containing 1, 10, and 20. 1, 10, and 20. So that's how I would write out each of those sets. They're given to me kind of in words here, and I write them down in set notation in those curly brackets with all the numbers separated by commas. Okay, so we're going to use those sets, the sample space, J, K, L, and M, to answer some questions. Okay, so first question, this is read, is M a subset of K? Remember this horseshoe on its side means a subset. Is M a subset of K? So looking at set M, what a subset means is every element of set M must also be in set K. Well, let's check. Is 1 in set K? No. Is 10 in set K? Yes. Is 20 in set K? Yes. So 10 and 20 are in set K, but 1 is not. So is M a subset of set K? No, because not all the elements of M are also in K. So that would be the end of the answer to that question. That's it. Next question, is L a subset of J? So here's L. I have 2, 3, 5, 7, 11, 13, 17, 19. Is L a subset of J? Let's double check. Is 2 in L? Is 2 in J? No. Is 3 in J? Yes. 5? Yes. 7? Yes. 11? Yes. 13? 17? 19. So all but 1, all but 2 are all from set L are also contained in set J, but that's not enough to say it's a subset. In order for L to be a subset of J, that means everything in L would also need to be in J. So no, L is not a subset of J. Okay. Next question says, what is K intersect M? What is the intersection of sets K and M? So if you reflect back to our notes here, an intersection, this little cap here, means everything in K and in M. So I'm going to go through K and M here and see what elements are contained in both of these sets. So let's see, I have a 10 that's in both of these sets. I have a 20 that's in both of these sets. And that's it. So the intersection of K and M equals the set containing 10 and 20. So that's how I would write that answer. The intersection of sets K and M is the set containing 10 and 20, because those are the only numbers that are contained in both set K and set M. Okay, how about J intersect K? So let's now look at J and K. So I want to find the numbers that are in common between the set J and K, the numbers that are in both J and K. That's what an intersection means. J intersect K. So let's look here. I have a 5 that's in common between both of these. I have a 15 that's in common between both of these. And that's it. So the intersection of set J and K is 5 and 15. J intersect K is the set containing 5 and 15. In other words, 5 and 15 are in set J and set K. Remember, and is that big word that we talk about with an intersection. And that's with this little cap, the horseshoe pointing down. Okay, next, and again, all these questions here are on your guided notes. Here, what is J union L? That's what this little U means, J union L. So we're looking for all the elements that are in either set J or set L. So J union L, I don't like that. Okay, equals what? So here's set J, here's set L. So I'm just going to go ahead and start listing all the numbers in order. I have a 1, a 2, a 3, a 5, a 7, a 9, an 11, a 13, a 15, a 17, and a 19. So let me explain why I wrote all those numbers down. So 1, 2, 3, 5, 7, 9, 11, 13, 15, 17, 19. So I wrote down every number that was in either J or L, all in order here. 1, 2, 3, 5, 7, 9, 11, so I didn't repeat any of the numbers. That's the union of set J and set L, because it was all the elements that are either in set J or, that's what union means, or set L. Okay, let me erase all those real quick. So now the next question here wants me to find what the union of set L and M are. So I'm trying to find all the elements that are either in set L or set M. Well, I have a 1, 2, 3, 5, 7, 10, 11, 13, 17, 19, 20. In order, I had 1, 2, 3, 5, 7, 10, 11, 13, 17, 19, 20. Those were all the numbers that were either in set L or set M. All the numbers only listed once, written in these curly brackets. So those are some examples of unions of sets. Okay, next we're going to talk about some complement problems. So what is the set J complement? Or in other words, what is the complement of set J? So what that means is I'm looking at set J. I'm trying to find all the numbers that are not in set J, but are still in the sample space. So notice here, J complement, what are the numbers that are going to be in here? Well, I have a 1 in set J, I don't have a 2, I have a 3 in set J, I don't have a 4, I have a 5, I don't have a 6, I have a 7, I don't have an 8, 9, I don't have a 10, I don't have a 12, I don't have a 14, 16, 18, or 20. So all the even numbers there. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So again, the complement of set J, or J complement, is all the numbers that are in the sample space, but not in set J. So set J was all of the odd numbers between 1 and 20, so the complement of set J was all the even numbers between 1 and 20. Next, I'm asked for K complement, or the complement of set K. So I'm wanting to find all the numbers that are not in set K, but are still contained in the sample space. So I have 5, 10, 15, and 20 in set K. So that means 1 through 4, 6 through 9, 11 through 14, and 16 through 19 are all numbers in the sample space, but not in set K. So let me draw my curly brackets. I have 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, 19. Those are all the elements in the sample space, but not in set K. And that's the meat and potatoes of what we're talking about here. That's all the different types of sets, the notation associated with these different types of sets that we're going to talk about, that we're introducing ourselves to help us with what we're going to be talking about in the upcoming units when we start talking about probability. So if you're feeling good, the rest of this video is going to be working on homework problems. So this is off of your homework. It's questions, I think it ends up being questions 13 through 18. So if you have your homework out or you want to print out and follow along here, feel free to do so. So it says, use the sets given below to answer questions 13 through 18. Write your answers using set notation. So here's my sample space, the numbers 1 through 10. And then set A is the elements 1, 2, 3, 5, and 8. Set B is 4 and 8. Set C is 2, 4, 6, 8, and 10. So first question, this is read, is B a subset of A? Again, in other words, that means, are all the elements of B also in A? So in B I have 4 and 8. So let's look at set A, because if B is a subset of A, then 4 and 8 must better be in set A. I have an 8 here, but I don't have a 4, so no. B is not a subset of A. Is A a subset of B? Well, let's look. Is A a subset of B? That would mean all the elements of A also have to be in B. So do I have a 1, a 2, a 3, a 5, and an 8 in set B? No, I do not. Bummer. That's okay. Next one says, is B a subset of C? So that means, are all the elements of B also in C? Is there a 4 and an 8 in set C? Well, alas, yes, there is. So yes, set B is a subset of set C. Good. Again, that's what this little sideways horseshoe means. Okay, next question says, what is A intersect B? That's how this is read with the upside down horseshoe. What is A intersect B? Oh, whoops, this was no. So I need to look at set A and set B, and I need to look at all the elements that are in set A and in set B. Let's see, I have an 8 that's in both of these sets, and it looks like that's it. So A intersect B is going to be equal to the set containing 8. That's it. That's all that's in both A and B. Okay, next one says, what is A union C? That's what this little U means, is union, which means what are all the elements that are either in set A or set C? So let's say I have 1, I have a 2, 3, 4, 5, 6, 8, and 10. So A union C, I had 1, 2, 3, 4, 5, 6, 8, and 10. Again, because A union C is all the elements that are either in set A or in set C, all just listed once. Okay, and then the last question says, what is a complement? A complement means, what are all the elements that are not in set A, but still contained in the sample space? So I have a 1 here, a 2, a 3, a 5, an 8. So what numbers are left in the sample space that were not in set A? Well, they are 4, 6, 7, 9, and 10. 4, 6, 7, 9, and 10. Those were all the numbers, all the elements that were not in set A, but were still contained in the sample space. That's what a complement means. So that's a helpful little section of your homework for you, questions 13 through 18. And that's all I got for you today. That's all that's contained in this first lesson, set notation. Again, this is going to be a really good preparation for the rest of this unit on probability. Again, by the end of this lesson, I was hoping that you're able to write a sample space in set notation, meaning in those curly brackets. I want you to know what a subset is and be able to tell if one set is a subset of another. And I want you to know what the union, intersection, and complement means and find them given different sets. So I hope that was helpful. So please, again, let me know if you have any questions, and I hope that you enjoyed that as much as I did.